Okay, so we're doing section 5.4 in your book on page 254. This is kind of a culmination of everything that we've been doing. So far, you've learned to solve systems of equations, and you've learned that there is how many solutions to a systems of equation? 1. So, to know that there is one solution, what is happening to those two lines if there's one solution? They're intersecting. Okay, so at a point. That's if there's one solution. Now, there is another possibility when there is no solution. And that is when the lines are parallel. The last possibility is if there is infinitely many, and that is if the lines are the exact same line. Alright, so when there is one solution, there is, the slopes have to be different, and the y-intercept also has to be different. If there is no solution, what do you notice about these two slopes? They're the same. But what do you notice about the y-intercepts? They are different, because they're crossing the y at different points, but the slope is the same. For this one, the slope has to be the same. The y-intercept has to be the same. Okay, let's do some problems. Now, I'm going to do monitoring progress 1 on page 255. So, you've learned how to solve equations by graphing, by using substitution, and by elimination. Whichever way you want to solve it is up to you. So let's look at monitoring progress 1. How would you like to solve this? Elimination. Yeah, let's use elimination. We just did that one. So what do I multiply it by? Top equation, very good, by? -2. Okay, let's rewrite that. -2x minus 2y equals -6. Aha! That is out, that is out, and that is out. So 0 equals 0. So if the numbers come out, if it comes out to be 0 equals 0, which is always true, if the variables cancel out and the number comes out to be exactly the same, 6 equals 6, 5 equals 5, the answer is infinitely many solutions, which means the line is the same line. Now let's go back and look at the equation. Just look at the two original problems. Notice, if I divided everything by 2, would I come up with the same equation? Yeah, I would. If I divided this equation by 2, I'd come out with x plus y, which means that it's exactly the same line. Okay, so I'm going to do monitoring progress over again because my student Sasha in period 4 caught my mistake. So we're going to use elimination. That means that we have to move this first equation around. If I move over the negative x, it becomes positive x plus y equals 3. Okay, I'm going to multiply the bottom equation by -2. So, here's the first equation. I'm going to rewrite the second equation. I'm going to add them. Oh, look. Those cross out and become 0. 4 and -6 is -2. Is that true or false? False. That means this is no solution, which means the lines are parallel. Okay, we're going to do one more problem, monitoring progress 3. How would you like to solve this? Elimination. So we're going to multiply everything by -1. So let's do the top one. It's fine. -x, -y, -3. These become 0. -1y and 2y become y. -3 and 4 is 1. Yay! I have 1 point. Okay? Let's plug it in. Let's use the first equation. X plus 1 equals 3. X equals 2. Okay, so that means that this has one solution. You don't need to write one solution, you only need to write the points. That's how I know it's one solution.